Welcome to The Explainer. I am so excited to share this one with you today because honestly, we're going to completely shatter how you think about your own body. We are going to explore what is arguably the single most miraculous, reality-bending event in all of nature, and that's embryogenesis. I mean, think about it. How does a single microscopic cell turn into a fully formed human with high-level cognition, complex organs, and a rich inner life? And the craziest part of all this, it happens entirely without a magical lightning bolt. It is just a smooth, unbroken continuum. Let's dive right in.
So, for decades now, we've been completely stuck in this genocentric view of life. We've treated DNA as this ultimate, unchangeable blueprint. We've basically assumed that every single biological action is hard-coded into our genes right from the start. But the new reality we're discovering is actually much stranger and way more fascinating. DNA isn't the blueprint at all. It's really just a parts list. Assuming that DNA hard codes our anatomical shape is a lot like having a software glitch on your laptop and trying to fix it by literally melting down the physical copper wiring. You are fundamentally looking at the completely wrong layer of the problem. And, that begs a pretty obvious question, right? If DNA merely provides the hardware, like the proteins, the structural building blocks of the body, then what exactly is the software? Well, pioneering biologist Dr. Michael Levin proposes a truly brilliant answer. He argues that the reprogrammable instructions telling our collective cellular hardware what shape to build is actually bioelectricity. It's this hidden, dynamic electrical network just humming away, connecting every single cell in your entire body. This concept brilliantly illustrates why our current medical paradigm often struggles so much. As the saying goes, you don't use a soldering iron to close Photoshop. But think about it. Traditional medicine relies heavily on pharmacology, which targets specific physical protein receptors. We are essentially applying a highly localized hardware fix to a massive systemic software bug. And that is exactly why you get those huge, widespread side effects, and why symptoms almost always return the second a drug washes out of your system. We've literally been trying to edit a digital document by yanking out microscopic transistors. All right, moving on to Section 2, the body's electric software. Let's look at how wet, squishy cells actually compute. Believe it or not, the answer actually dates all the way back to the 1800s, when a physiologist proved that a simple cut finger acts as a biological battery. Let's walk through how this built-in biological battery actually functions. Step 1, every single cell is wrapped in fat, a lipid bilayer, which acts as a perfect electrical insulator. Step 2, ion channels act as gates through that fat. And step 3, the cell actively pumps positive potassium ions in and positive sodium out. This creates a literal voltage gradient. And Dr. Minzhou actually proved that this electrical field dictates physical movement. In an amazing experiment, she applied an external voltage to migrating cells in a petri dish, and when she suddenly reversed the polarity, the cells literally stopped in their tracks, turned around, and walked backwards. The electricity completely overrode all their other chemical signals. Okay, so let's dive into the core machinery that makes this kind of biological computation possible. Behold the voltage-gated ion channel. This is basically a protein pore whose physical shape, meaning whether it twists wide open or slams tightly shut, is directly controlled by the electrical charge surrounding it. And because its opening allows charged ions to flow in or out, which in turn changes the surrounding voltage, which then affects the channel itself, you end up with an incredibly elegant, built-in biological feedback loop. This brings us to a crucial point, summarized perfectly by this quote. Evolution got the same computational component that powers my computer for free. Think about that. A voltage-gated current conductance is the exact physical definition of a transistor. Evolution basically gets logic gates, truth tables, and memory storage, native on every single cell membrane, straight from the laws of physics. Every cell you have is completely covered in biological transistors. Section 3, the cellular mind meld. This is where we see how cells forget they are individuals and wire themselves together to form a collective intelligence. Because, let's be honest, a single transistor sitting alone on a desk doesn't really do much, right? For this electrical software to scale up and build a body, millions of cells have to connect. So how do they do it? Through something called gap junctions. Think of these as highly specialized submarine hatches. Each cell produces a ring of proteins, and when they dock with a neighboring cell, they lock tightly together, creating a physical tunnel. This tunnel allows them to share ions and vital secondary messengers, like calcium. And calcium is incredibly important here, because a sudden spike in calcium is effectively how a cell records a memory of an event, like physical stress or damage. Now, this creates a massive philosophical mind bend. Normally, a cell has strict boundaries. It knows a signal came from the outside world, but when calcium flows directly through a gap junction, it entirely bypasses those external receptors. This essentially strips away the ownership metadata of that memory. If cell B feels the exact physical calcium spike from cell A's stress, they lose their distinct identities. They are forced into a unified cognitive glue. They become one. This whole concept leads to Dr. Levin's multi-scale competency architecture. Basically, biology isn't a top-down dictatorship. The higher levels simply bend the option space, gently nudging these highly competent, problem-solving lower-level cells. My absolute favorite analogy from the source material is this. It's like building a tower out of live dogs instead of Legos. The pieces figure things out on their own. In one mind-blowing experiment, tadpoles had their faces surgically scrambled. We're talking eyes on the back of their heads, jaws completely shifted. But instead of growing into disfigured monsters, those individual cells autonomously navigated completely novel, unpredicted paths to successfully form a totally normal frog face. Section 4. Programming two-headed worms. Let's look at the ultimate proof of this bioelectric software. So, if this network truly holds a software state, a real anatomical blueprint, then logically, just like a computer, we should be able to rewrite it. Check out this number, 276. In a classic experiment by Thomas Hunt Morgan, a single planarian flatworm was systematically cut into 276 separate pieces. And incredibly, every single fragment, no matter how ridiculously tiny, somehow perfectly calculated exactly what part of the body it used to be, figured out what was missing, and regenerated into a perfect miniature worm. The DNA is exactly identical everywhere, so it absolutely has to be the electric network providing the map. To definitively prove this, Levin's lab performed the barium experiment. Barium acts like a microscopic cork. It perfectly wedges into those potassium ion channels and gets totally stuck. This completely halts the electrical flow, closes the gap junctions, and violently shatters that cellular mind meld. The terrifying results? The cells in the flatworm's head wake up as isolated, confused individuals. Without the software command telling them to maintain a head, the tissue undergoes deprogression and literally explodes. But breaking the software is one thing. Actually rewriting it is another entirely. Using voltage-sensitive fluorescent dyes, the lab could literally see the glowing electrical blueprint outlining the worm's shape. Then, using specialized drugs called ionoseuticals, they manually forced specific channels open and closed. They successfully incepted a false memory on the tail end, calling for a second head. And the craziest part? They did all of this without ever touching a single strand of the worm's DNA. Once they incepted that false memory, they amputated both the head and the tail. The middle fragment consulted its bioelectric network, read the new software, and grew two heads. But wait, here is the absolute craziest part of all. Even after all those drugs completely wash out of its system, if you take that new two-headed worm months later and chop it into pieces, it will infinitely regenerate as a two-headed worm forever. The DNA is perfectly normal, untouched, but the rewritable software has been permanently altered. Section 5. Healing, Cancer, and Xenobots. Unlocking New Life. Now, these wild lab experiments have massive, real-world stakes for human health, synthetic biology, and how we treat disease. Let's start with cancer. Under this new framework, cancer fundamentally involves an electrical dysregulation. Think about the typical sequence. When an oncogene activates, the very first thing it does is slam those gap junctions shut. The cell abruptly disconnects from the bioelectric network. Its boundary of self shrinks down to just itself. It's essentially, well, it's like a dissociative identity disorder of the tissue. Completely isolated, the cell just reverts back to ancient amoeba programming. It just eats, multiplies uncontrollably, and metastasizes. So, the crucial point is how we actually fix it. Levin's lab took tadpoles and injected them with blazing hot human oncogenes, but at the exact same time, they used those ionoseuticals we talked about to manually force the gap junctions to stay open. The result? 0 tumors formed. None. It turns out you don't necessarily need highly toxic chemotherapy to kill a cancer cell. You might just need to electrically reconnect it to the mind meld so it remembers what it's supposed to be part of.
And what happens when we completely untether cells from their typical everyday instructions? We get engineering by subtraction. Scientists isolated simple frog skin cells, freed them from the embryonic social pressure of the network, and did absolutely zero genetic editing to them. Astonishingly, these liberated cells spontaneously self-assembled into entirely new swarming organisms called xenobots. And these brand new entities are wildly capable. Xenobots can navigate mazes and even achieve kinematic self-replication. They act like biological snowplows, pushing loose cells into piles that then boot up into brand new xenobots. Meanwhile, we have anthrobots. These are created from adult human tracheal cells, and they actually reverse their epigenetic age, literally turning back their own biological clock. In a petri dish, they will spontaneously find human neural wounds and stitch the neurons back together. It definitively proves our hardware holds this massive latent space of unevolved healing possibilities.
Section 6. Redefining the self, the boundaries of the mind. We are rapidly entering an era of somatic psychiatry, where something like a brief 24-hour electrical prompt could cause an adult frog to regrow a completely severed leg. It all comes down to what's called the cognitive light cone. This is basically the scale of goals a biological system can actively pursue. A single isolated cell has a tiny light cone. It really only cares about its immediate local environment. But when gap junctions merge these cells together, their cognitive light cones combine and expand. Suddenly, a 10 million cell network can collaborate on a massive, complex goal, like building an entire femur bone for that frog over the course of several months.
And all of this leaves us with a staggeringly profound question. As biotechnology continues to advance, what happens if we invent synthetic gap junctions? What if we can connect human tissues directly to computers, or even, crazy as it sounds, to other people? If our memories and our physical goals can flow fluidly across boundaries without ownership metadata, where will you end and the rest of the world begin? Could a literal electrical mind meld one day cure our ultimate physical isolation? It is an incredible thought to chew on. Thank you so much for joining me on this explainer, and keep exploring the hidden software that shapes our world.